Hello everyone. Today we will be looking at the matrix calculations for translation. Now in the first part, if you can remember, I showed you a practical demonstration with CSS, how this transformation can be used in web development. And let's look at the mathematics part today. This is also the second part, and then we can go to the matrix calculation. So we are going to start with 2D, and then we will look at the 3D transformations. Now, in order to see how these translations are happening, we are going to use a reference. So as reference, we will start with points first. So we know that set of points create up a shape. So if we have one point in 2D space or 3D space, that can be uh, like positioned or rather represented using x comma y in 2D space and x comma y comma z in 3D space. But if you have 2 points, we can call it a line where each point has their own kind of coordinates. And then if you have 3, then we can make it a triangle. And of course, if we have 4, we can call it a face, or otherwise known as a quad. So that is what we are working with, the rectangle quad. Uh, but note that rectangle is also represented as a vector using 4 points in 2D space. So let's call them A, B, C, D. Now, if you have information about 4 points, and if you want to make a rectangle in any graphical environment, you have to pass this information to something called a rasterizer. A rasterizer there are different type of rasterizers available, but basically most of them will accept lines, 2 points. So you can have like something like AB, which talks about 2 points and basically makes up a line. And again, you can see something like BC, and also I can pass to the rasterizer CD and DA. So if these values are passed to the rasterizer, then it can generate the rectangle. Again, it can be generated in different ways, but if you think about the current passing of the values, that's AB. um, Let me connect BC as well. Okay, and CD, and finally DA. So connecting these points will give you the shape that you need. So the computer can, or basically the program or your graphic environment can generate the rectangle. And of course you can use any fill colors or anything, solid color or a fill color, or even a gradient or an image, depending on the square or other the square area you can fill up with colors. So these rasterizers usually they allow you to do that. And just to show you, if I create a couple of points like this, so imagine that I'm passing these points to the rasterizer. So rasterizer can draw it like this. I'm drawing this on my screen, you can see. So first off, we have to pass the point values, and after you do that, the rasterizer can start connecting the points so that they are forming the line as you want. So if we name all the points and we pass the line values, so if I connect this to show you how it works, we can see rasterizer will draw by connecting these points. Okay, that's complete. And let's put the eyes, just example. Okay, here you go. So it doesn't really like draw by skipping or anything. It just depends on the two line values or point values that you're passing. Then the drawing can happen. So this is how your computer program usually draws up the shapes or vector shapes onto your computer screen using these point values. it doesn't have to be something like that. So if we are talking in reference to the original ABCD square that we had, so it can be passed in different ways as well. Now we passed it as A, B, B, C, C, D, and D, A. But if we pass different values, for example, if I pass A, C, and let's say B, D, then the rasterizer will draw the point like this maybe. So there can be different types of or rather different ways of passing the values. So it doesn't necessarily have to be passed in a certain order. So rasterizer can draw it on the way or using the way that you're passing these point values. That's also something that you have to keep in mind if you are trying to generate 2D or 3D spaces or other shapes using a rasterizer. Again, rasterizer can be any form of a drawing software which allows you to generate shapes onto the computer screen. Okay, there are so many examples that you can take. Even the CSS one that I showed you is an example. So what we are really looking at today is how you can manipulate this shape, like rotate it, scale it, and move it. So what we are really doing is we are taking a point and we are modifying its value, its location. And in relation to that, if we change the points A or B and sorry, A, C, and D, we get the new shape. So you can rotate point B about an axis or around the axis, or maybe you can move it. Scaling means again a movement of scale factor. So that is what we are going to look at in the next part. Okay, so to discuss about the transformations, let's draw up our diagram. So let's draw axis. Now, like I said, we are going to start with the 2D space first. So let's draw our x-axis and our y-axis. Let me name these. Okay, so it's easier for us to represent uh, x and y. All right, so what I'm going to do is I'm going to draw the same rectangle that I had on this axis. So we have the 4 points, or rather the square here, and then we can generate the 4 point from it. Let's say that's point AB and BC, CD, and DA. All right, simple as that. Let me mark the points as well. So let's call this width as W. So, and the height, let's call it as H. So let's say for this reference, width is equal to 1 and height is equal to 1. Let me highlight the 4 points. Okay, now if the W is equal to 1, that means AB is equal to 1, then the value of this point should be half. So that's half, right? Draw this again. This is half. And the Y value here is also half. So because H is equal to 1 and W is equal to 1, so that's half and half. And similar way, the point on the left, this will be negative half and half, and this will be negative half, and this will be half and negative half. So these are the point coordinate values in relation to the shape or other 4 points that I have drawn here. Okay. So really we have to talk about three translations actually: the scaling, the movement, or like moving the points, and the rotation of it. Now let's start with the scaling first. So let's start by looking at the scaling. So if you want to scale, let's say this particular rectangle, let's write it as x prime. So when I say x prime, it's the new position of the x value of this point. So let's whenever I say x prime, I'm talking about the new position. So we can say x prime is equal to some scalar in x. Let's call it as sx. So the scalar can be a negative value or a positive value, and scalar into the original x value. So we get x prime as equal to sx into x. In now, for example, if you think about this point, if you multiply this by a scalar, it can either move in the x direction, in to the right if it is positive, to the left if it is if the scalar is negative. So we get the x value, and we in the same way we can say scalar y, or rather y prime, of this particular point is equal to some form of a scale in y. Let's call it as sy into y. So if I write it here, the y prime is equal to scalar y into y. Now let's take it as a real world example. Now at the point B we have half for the x and half for the y. So imagine that the scalar is 2, sx is 2, and sy is also 2. So if you multiply x, which is half, by 2, we get 1. So the new value of the x will be 1, and in the same way y prime is equal to sy, that is 2 now, since you are scaling it by 2, and y is half, so 2 into half becomes 1. So the new point will become x equals 1. So x prime is equal to 1, y prime is equal to 1. So if we draw that on the graph here, let's draw the new point. It's going to be right here in the x and going up to the y right here. So we have to do this for all the 4 points. So in that case, this one is negative half, and half for the y. So negative half into 2 will become valid there. So you can see the new points will scale like that. So if you combine or draw the lines, right, so we get our new scaled rectangle. Note that I have multiplied or scaled all the points of the rectangle. Okay, if your shape has, let's say, 10 points, all the 10 points have to be multiplied from the scalars individually, and by connecting you will get the shape. So scale is pretty much self-explanatory and very intuitive. It's very easy to understand, nothing advanced about it. Okay, now let's look at the translation. Now translation is simply another word for movement. Okay, if you're moving a point. So translation is extremely simpler to understand, just like the scaling. There's nothing complex about it. So let's write this. So x prime, if I want to move translate the point, x prime will be equal to the initial x value, which is the original point and the movement. So plus, let's say, the movement A. And same way we can write the y prime, that means the new y value is equal to the initial y value, which is y, plus the amount translated in the y-axis, let's call it b. So we can say x prime is equal to x plus a, y prime is equal to y plus b. So the a and b can be a negative value and a positive value, again depending on the movement that you need. So it is very straightforward, where you can apply a value and get the new x and y coordinates. Extremely simpler to understand. Now let's assume that a is 1 and we want to move it by 1, and the b is 0. So if we write this equation again, so I want to move this point, all the points of x, that means x prime. So all the 4 points should be moved in x by 1 point, and all the points in y prime, that means y values, should not be changed because b value should be 0. So if you are to write this to indicate this value, let's say x prime now will be equal to the original x of the point here will be half. So half plus 1, that's going to be 3 halves. So let me write it so it's clear to you. Okay, so x dash now is equal to x was half plus 1, because a is equal to 1, and that's going to be 3 halves. So x prime of the point B will be 3 halves, and for y prime for the point B, it's half plus 0, so it becomes half, so no change. So that's the new x prime and y prime for the point B. Now we have to do this for all the 4 points. So if we think about 3 halves and half, the point is going to be right here. And let's think about point A. So point A has negative half. So negative half plus 1, that becomes half. So the point will be right here. And let's think about point D. So point D again has negative half. So it becomes positive half now. And point C is half, so that 3 halves. So if we draw all 4, you can see no change in y, and we haven't scaled it also, so it's in the same size. So we get the new rectangle right here. You can see we just have moved it to the right because there's no change in the y. If you only change in the x, we are moving it to the left or right. If you had negative values, then we will be moving it to the left side. And along with this, you can change the y values as well. So if you change the y values, so you can move it up and down. So that's also something that you have to understand. So this is movement in a nutshell, easy to understand. So after this, we will be looking at the rotation. So scaling and translation is kind of simpler, and there's nothing complex about it. It's just you have to look at the number of points that you have on the shape, and then figure out the new coordinates or new movement that you need and redraw the shape. So that's how a rasterizer will draw the object on your computer screen. So for the rotation, we are going to use a bit of trigonometry to come to the matrix that we are looking for. So we in scale we had the scalar x and scalar y, and for the translate we had the a and v. So in the same way, we need to have certain two factors for the rotation. So what we are going to work with is the angle. So if we assume that we have a point in the rotation, we are moving that point by around the axis or about an axis in counterclockwise maybe or clockwise by a certain angle. So before anything, let me write this equation so you can get a head start, and then I will explain how you get this. So I can write x prime after the rotation. My new x value is equal to x cosine of the angle, x into cosine of the angle, and minus y sine angle. So this will give me the new x coordinate value. That means my x prime. So x prime is equal to x into cosine of the angle minus y into sine angle. And I also can write my y prime, which will be equal to x into sine of the angle plus y into cosine of the angle. So now you will be wondering how I get this value. So that is what we are going to discuss in a bit in detail. So just keep this in your head that okay, this is what we are getting, what we need to come at. So we need to derive this equation, and let's see how the rotation uh, works, and from that how we can derive this equation. So I need to have a new graph for this one. So let me draw a new graph with two axes. So you're going to have the x-axis and y-axis. Draw it somewhere that we have space. This is better, right? So that's y-axis and my x-axis. Okay, let's put some arrows so that it's easy for us to understand. Let's use a different color for this, and mark our point on this graph. So assume that our point is right here. Okay, so we have some x value and y value, and then just draw a line to indicate the rotation. Like that. Okay, and we are going to assume that this point has been rotated initially, so that angle is right here, the angle that you can see on the graph, and this is the y value. So let's call this angle, the rotated angle, as alpha. Let's name it as alpha. All right, and this is also alpha. That's also alpha. Let's name it as alpha. So this has the initial rotation. Please note that you can assume that there's no initial rotation for this point as well. You can assume that the point can start either on the x-axis or the y-axis. However, for this demonstration, I will assume that we have a initial rotation. So this point coordinates will be x comma y. So this is the point x comma y. Now how we can represent x comma y? Now you know the rules of trigonometry, and just to show you, if I draw a line from the point x to the x-axis, x comma y to the x-axis, you can see it's a 90-degree angle. Okay, so we can represent x and y using their sine and cosine values. So that is exactly what you're going to do. Let me take a different color, and okay, if we have to draw a line like this, it's a 90-degree angle. Now can you think of a way to represent x and y? How can I write x? So x is equal to what? Think about it for a moment, because you have learned about it already. Yes, so it's a very simple answer, isn't it? So x is equal. So x is equal to the cos alpha, and the y is equal to sine alpha. Let me write this here. Now x is equal to the cos alpha and y is equal to sine alpha. There we go. Okay, so that's the initial rotation that we have. Now, assuming that this point will be rotated by another angle, let's call it theta. So this point is going to be rotated by another angle theta. So let me draw the new point position. So we can say somewhere around here. So that's the new point. So here also we can draw 90 degrees. Okay. And now that new angle, let's call it theta. So here is the new angle. Right. And this is also theta. Right, so let's mark the new point here. So after you rotate the point by alpha, then by another theta. So you can write, you can draw the point, you can indicate the point right here. Okay, now here we can say this point is our x prime and y prime. So this is where we need to find a relation or equation for us to get the values for the x prime and y prime. That's a new point. So now we think about it. How do you get a value? How do you get the equation for x prime and y prime? We know that this point has been rotated already by an alpha angle, and on top of that it has been rotated by another theta angle. And we also know that the previous angle, the x and y, can be represented using the cos alpha and the y using the sine alpha. So from those information we can indicate, let's say, x prime and y prime. So x prime is equal to, now we know it's a cos value that we need, so we can say cos alpha plus theta. So that is our new x prime value, because x prime, again, it's a summation of the alpha and angle alpha and the theta. So we can say x prime is equal to the cos value of alpha plus theta. You can write it here. All right. Now in the same way, I can write the y prime also. Now, can you guess what's the y prime is going to be? Because y is equal to sine alpha, so new y prime is again the sine value into alpha plus theta. So let me write that as well. Y prime is equal to sine alpha plus theta. Now what you can do is you can write this x prime and y prime, and you can expand it, and you can do a small trick here. Now you know this already, right? You know how to multiply this and write it. So let me write this on behalf of you. So we can say x prime is equal to uh, cos alpha plus cos theta minus sine alpha sine theta. Okay, we don't know how you get this theta plus alpha, the cos value multiplication. Please look into it. So I'm pretty sure that everybody knows about this, but please Google it if you don't know how you get this. Okay, so if you multiply two angles, summation of two angles from the cos value, you get x prime is equal to the cos alpha cos theta minus sin alpha sin theta. So let me write it. Okay, so we can, similar way we can write the y prime. So y prime, we are multiplying the sine value of two angles, so we can write it as, again look it up if you don't know, so it's cos alpha sin theta plus sin alpha cos theta. Simple as that. Now we have two values for the x prime and y prime. Okay, so now we need to give a meaning to this equation, so that's why we have x and y written. So we know that x is equal to the cos alpha and y is equal to sin alpha. So if we have in this equation cos alpha and sin alpha, we can replace it with x and y. So let's look at our equation. So x prime is equal to cos alpha cos theta, so we can replace the cos alpha there by x, and also we have the minus sin alpha sin theta, so sin alpha can be replaced by y. In the y prime also we can replace cos alpha with x, and we can replace sin alpha with y. So let's go and replace. So cos alpha here is x and sin alpha is y. Let me draw a reference in this the board as well, so you have the idea when you're referring to it. Okay, put my arrow. Okay, that's clear. So if we are to write this equation again, so we can write x prime is equal to so we can replace this by x because cos alpha is x here, so x into cosine theta minus, so sin alpha is y, so we can say y sin theta. In the same way we can write the y prime, so y prime is equal to, so again cos alpha can be replaced with x sin theta plus sin alpha is y, so we can say y cos theta. So does it sound familiar now, the initial equation that I have written for the rotation? So this is the same thing, right? There you go. So initially if we look at it, we had the angle alpha, but in the derived equation that we have here for the x prime and y prime, we don't have alpha. That's why I said in the beginning that even without having the initial rotation, we can do the calculation. If the initial rotation is 0, that means if the original point was on the x-axis or y-axis, then in that case alpha would become 0. So let me show this here. So if the original point was on the x-axis or y-axis like this, yeah, the alpha will become 0. It doesn't really affect our calculation because you can see in the x prime and y prime we don't really have alpha. So it's all about the angle theta. So because the total angle is taken as theta. So that's something that we have to understand and keep in our minds. Initial rotation is something that we really don't care about here. So we can derive x prime and y prime using this equation, and we can write this in matrix form. So in the next part I will show you how we can do this as well. But just to show you what sort of rotation that we are talking about, so let me get rid of these and draw our rectangle again. Okay, let me clear this up. Alright, so the scale was self-explanatory. We had the x dash, x prime and y prime scaled by scale factor sx and sy, and translation added by a and b. And rotation is basically we have the cos value and the sine value. So if we are to draw this rectangle with 4 points right here. Okay, let me connect these. So whatever the transformation that we are doing, either it's scale, translator, rotation, especially with rotation, so we have to calculate the x prime and y prime for all the points of this shape. So then we know the position of each point after the rotation, and we can redraw so that the rotated object can be drawn. So I have drawn the rotated one. You can see the points of vertices, that means the corners, right? The 4 points has been changed from the original position. And by the one that I have drawn, you can see it has been scaled also from the points there, and maybe it has been translated as well. Can't tell from this, the one that I have drawn, and obviously it is rotated as well. So this is just to identify the relevance um, of how this scaling, translation and rotation works. Now imagine that you have a 3D object to be rendered along with other shapes, and it's need to be moved and rotated and scaled. So a complex 3D object might have a couple of million vertex points. So each and every point new values should be calculated. So it's a vector calculation. So we have the scale factors and the translate A, B, O. We have the sine and cos values of the angles of the rotation. We can recalculate and regenerate and redraw the shape on the screen. So uh, in simple form, for a rectangle, this is what happens. So, but for each point, each vertex, you have to calculate this and get to know. So this is the part 2 of the matrix transformation. So next part is to bring this into matrix form and how to actually write it as a matrix. So in that part we will discuss about it. So I'll post the next part quickly, and then we can discuss about it.